this, I was saying that if you have a low slump, you would be using it there in situations like for in case of a slab where the thickness of the slab is quite less. So you just have to pour the concrete over to the slab in quite less thickness. That would mean their low slump would be, so you usually go in this range, very low to low range, while you are casting a slab. Then in case of beams, and now beams would have greater thickness than in case of the slab. Similarly, foundations, where you have a footing like an isolated footing or any other wall footing like plinths you are constructing where you have a mass concreting, there the slump value would be between the low and the medium. So this is the range there in case of beams, in case of foundations, in case of various other structures. So it actually depends on the size of the structure in terms of its thickness. Thereby, what is to be noted from this slump, it gives you an idea of the workability, because workability itself is not it's a qualitative property. वो एक उसकी क्वालिटी बता रहा है कंक्रीट की. बट टू पुट इट इन टर्म्स ऑफ क्वांटिटेटिव बिहेवियर, ताकि हम इसको मेजर कर पाए, we use this test. It's an indirect method actually to note down, to determine the workability. Otherwise, it's not giving us the workability. It's not giving us the ease with which we are working. It's giving us something else, which is known as the slump value. And these are the slump values: 0 mm, 5 to 10 mm, 15 to 30, 35. So these are the range. Now, above 155 mm of slump, it's a flowing concrete. So there you cannot perform this test. So there we have a table which I told you this, the flow table test. The flow table test, there you have a table. This is the plan of the table, the top view of the table, and you pour the concrete onto this table. You pour it and it continues to flow towards the boundaries, towards the edge. So it now this flowing of the concrete, how much will it flow towards the ends of this flow table? That will tell you the flowability of that concrete. So there is a separate term in this test, which is the flowability. So there you are not measuring the slump value, you are measuring the flowability in that case. Now, where do we go for such large slump values, like above 200 and above 155, even 200, we usually go for slump values of that high amount. Where do we go for that? It's in the case of structures where the pumping concrete is used. Where pumping concrete is used, that's one. Second, in case of structures where we have concrete which needs to self-consolidation. Now, self-consolidation is the concrete itself is settling down. You do not need, or you hardly need vibrators in self-consolidation and test. So you have different use of concrete and its workability. Now, you will not be using a high workability concrete in case of slump value. That it means concrete जब आप beam में pour करोगे, for example, this is beam. Now you are pouring the concrete within this. Let me draw it like this. So if it has got high slump, it will ये नीचे ऐसे extend हो जाएगा towards the edge of this. So it will fill up in packs like this. Then there will be another pack of this. Then there will be third pack. So it will there will be packs or layers of this filling up the beam, each layer one above the other. There, there will be, if it's a good consistent concrete, I don't think there will be any problem in terms of कि flow अगर ज़्यादा है. हाँ, एक चीज हो सकता है, on the sides of this beam, the concrete, because it has got more flow, through the gaps it can leak out. There could be a lot of leakage from the gaps here. But the main issue is it's settling down in layers. So you are actually getting a concrete which is separated into layers, and that will not serve the purpose, because it will create a concrete in beam with layers one above the other, and there could be small joints, horizontal joints between the two layers, which you have casted earlier and then which you are casting later on, and you do not want that. Now if there is less workability, less slump value, in that case it will go right like this, like a cone, and settle down, and एक बैच में ही ये almost settle down हो जाएगा. Then you pour here, it settles down like this. You pour here, it settles down like this. You pour here, it settles down like this. So there is almost, if it has got low slump value, and because you cannot cast all the material together, it takes time. Around, you start from the morning and you end up in the evening casting over a large structure. So thereby you are getting here, the joints are not continuous. The joints are, they are crisscrossing. So you are getting wedge-like joints here. And not only that matters, what matters is that there is no shear, because shear would be like this. So it's actually checking the shear of the concrete, and the concrete would behave good in shear. Similarly, it would behave, beam has got a property of flexure, of bending. So it would behave properly in bending. A layered beam would not behave properly in bending. So this would behave properly in bending. So there are various things to be noted down why we require particular slump values in particular situations. Similarly, in the case of columns where we are using high slump value, there one of the dimension is quite less. This dimension is quite less, this dimension is quite less, and this dimension is quite big. So when you're pouring concrete, it settles down in layers, and this is good here in this case. Why? Because the load is a compressive load over a column, and the layers ultimately compress out. While as in beam, the layers would behave separately if you are actually casting in that fashion. In this case, the compression load is there, so it would behave in a more better fashion. Moreover, there would be one batch of mix which would settle down here, then another batch here, another here. So there is hardly any shear that acts on concrete apart from when you have lateral loads on the column. So it does not require shear um, resistance. The concrete does not require shear resistance. So here we require more flowability, and thereby we require, such that it settles down in layers, we require more flowability here in the case of column. So this is the reason for different values of slump values in different situations. The second test was the compaction factor test. I can just show you an example to the figure to define what is a compaction factor test. This is the compaction factor test. You have an upper hopper, a lower hopper, and a cylinder at the bottom. So they are like a cone, but they are and it's a reverse cone, as in the case of the slump test. Here they have lids. So you remove the lid, you allow you have poured the concrete in the upper hopper, you remove the lid from the bottom of this, it just flows down into the lower hopper in a fashion. In this fashion it will flow down. So क्योंकि ऊपर ज्यादा एरिया है, it will flow down and along with abrasion with the this hopper or the funnel, you can call it as well. It will have an abrasion with the surface of that. So what does that tell you? If there is an abrasion, it's actually depicting the ease of compaction or the ease of workability of the concrete. It's depicting that. So ultimately, from the lower hopper, it's going down into the cylinder or into the base. So there are two processes of this falling from one to the other, and the dimensions of this are 280, then this is 200, then this is 240, this is 200, then this is 285. These are the standard dimensions of this test. Now there is a factor which defines the workability here in this case, and that factor is how much is the, I just write it down, that's compaction factor. That's equal to density of actually, or you can say density actually achieved by concrete by density of same concrete which is fully compacted. Now you are testing a particular, now there is one which is fully compacted. आपने सिर्फ नीचे एक सिलेंडर था इसमें, the last one was a cylinder here at the bottom. So if you just take one in that cylinder, आप अलग से करोगे, उसमें concrete pour करोगे और उसको पूरा compact करोगे with a tamping rod. There is a tamping rod as well. This is the tamping rod here. This is the tamping rod. जिससे the cylinder is actually उसमें material को compact किया जाता है. Now you measure that. उस सिलेंडर में कितना कंक्रीट फुली कॉम्पैक्टेड, जब आपने टैंपिंग रॉड से उसको कॉम्पैक्ट कर दिया, वो कितना कॉम्पैक्ट हुआ और उसकी डेंसिटी कितनी निकली. सो डेंसिटी इज मास बाय वॉल्यूम. यू नो द वॉल्यूम ऑफ द सिलेंडर, द मास you will get by measuring on the weighing scale. Then what you do, you pour the concrete, you remove that, then bring the cylinder here, pour from the top hopper, it flows through the bottom hopper and goes into the cylinder, the concrete. So that is actually what is the compaction that is achieved in the real conditions. Even at the site, जब आप pour करते हो, even at the site, कैसे pour किया जाता है? It may be poured through a bucket. Bucket से ऐसे डाल दिया गया, तो फिर वो करनी से या छोटे से किसी लोहे के टुकड़े से उसको, he will just stamp it like this such that the concrete goes within the gaps. So that's all he will do. So that is the compaction, actual compaction that is achieved. So this test actually resembles what is actually achieved in terms of the density. So from this, when the concrete is going through here and then down into here, you will just pick up the cylinder, again measure the mass of the cylinder and check what is the density. So you are getting the actual density achieved from this test and to the same concrete which was fully compacted in the cylinder by tamping it a lot within the within that cylinder. So that this is the compaction factor test. So there are various codes that you are using in the compaction factor test. This factor actually tells you if there is a, if the factor is more, what does it tell you? If the factor is more, what does it tell you? If it's near 1, if this ratio is near 1, what will it tell you? Anyone?
उसकी वर्केबिलिटी ज्यादा होगी,
Its workability is,
आसान होगा वर्क काम करना उसमें.
it is easy. We are easily, it's getting compacted, right? Isn't it? So
Yes, sir.
it's getting compacted very easily. तो इसकी density easily achieve हो रही है. So what was the purpose of workability? To achieve a proper densification, the proper densification of concrete, or we call it proper compaction of concrete, or we call it proper consolidation of concrete. You have three terms here: densification, or compaction, or consolidation. So now these can be interrelated to each other: compaction, consolidation, and densification. Compaction, we usually say that you remove the air voids, and consolidation is you even remove the water from the. So there might be a slight difference, but usually we are here in this case we use it interrelated. We can use one over the other: densification or compaction or the consolidation. So near 1 compaction factor, it's full, it's easy to be worked on, and lesser you go below less than 1, and more less you go, that means it's it's not properly getting compacted, so it's not actually flowing properly, so it's not easily workable. Then it's not easily workable. So this is a better way of checking the workability in the qualitative term. क्या कौन सा workable है and which is not workable. So this test is giving a better picture of that. So there are even more tests, webby tests. I'll not go into because they are in special situations that we use for determining the workability. Now, here in this case, the last thing that remains to be studied is the stiffening of concrete. I have already briefly described this. What is stiffening of concrete? It's almost same like you have the setting of concrete. So there was workability was one aspect. Second is the stiffening of concrete, which has got something to do with the setting of the concrete. What is stiffening of concrete? It is the resistance that it is offering to penetration. So you have a penetrometer, which you mostly use a penetrometer in order to study how much does the needle of the penetrometer go into the concrete. So more is the resistance to the needle of the penetrometer going into the concrete, more. I'll just this is a concrete penetrometer, a test that you use. This one as well, concrete penetrometer test. So we actually are checking how much does it's banked on the back, and the torque is applied, so it goes into the concrete. Now, how much resistance does the concrete offer to this needle of the penetrometer? That is telling you the stiffening of the concrete. So stiffening is a good property of concrete. More it is offering the resistance to penetration. That means in the long run, it will be offering more hardness, and finally, it will be offering more strength. So it's 3.5 megapascal. We measure it in terms of the strength, the penetration that it's offering. at initial setting time. If we measure through the penetrometer, at initial setting time, it will offer 3.5 megapascal of resistance in terms of stresses that will develop. And at final setting time, it offers around 27.6 megapascals resistance to the penetration. So that's how, the readings are noted on that dial gauge of the penetrometer to the torque that's applied onto the penetrometer. So third important property of concrete, one was workability, second was this stiffening, third is segregation of concrete. Very important to discuss this. This is segregation, and then we have the final one, which is the bleeding.
So final setting में कितना आपने बोला resistance offer करता है ये?
7.6 लिखा हुआ.
Okay.
So the third important property is the segregation. Now, what is segregation? I told you this last time, that heavier particles settle down, which are the core segregates in a mass. They settle down towards the bottom, and the lighter particles, they move towards the top. So now in a consistent means in a consistent concrete paste, concrete mix, not paste, concrete mix, you would have aggregates, cement paste, and water in proper combination with each other. And even if they are admixture, they will be in proper combination, and they will be consistent throughout. The paste will be, the overall mix will be consistent. You will not have zones where there is only aggregates. For example, you are baking a cake, and if you're baking a cake, or if you, how do you achieve the consistency of the cake before you mix? Any one of you, how do you achieve that? Once you have achieved the consistency by proper mixing in the mixer for concrete, now I am talking about concrete now, then you do not want it to segregate back. पहले आपने mix कर दिया properly in this, then you do not want it to segregate. So what do you do for it not to segregate? You do not allow it to fall from height. If you allow it to fall from height, it will fall down like this, and it will throw up like this. So it will actually segregate into different particles. So falling from the height is not good, because it again disintegrates. There is no consistency then. That's one thing. The second is your if you have mixed now in a mixer first, you are mixing in a mixer, and if you mix a lot, you keep on mixing, even after 5 minutes you are keeping on mixing in the mixer, what eventually happens is that the concrete loses its because the concrete begins to lose its plasticity, and then the particles begin to reframe. वो अपनी अपनी जगह पर मिक्सर में वापस आना शुरू करते हैं once it's beginning to lose the plasticity. So you do not mix for a long time. After 5 minutes, not allowed in most of the cases, not to mix more than 5 minutes. So you have to keep that into account, that you do not mix a lot. The third thing is the water. Water is very important. Now, if you have low water to cement ratio, which I was discussing the last time, water to cement ratio, if you have low, it's less prone to segregation. जितना आप पानी को कम रखोगे, उतना segregation होने के chances once mixed consistently कम रहेंगे. क्यों? क्योंकि जितना आप पानी ज्यादा रखोगे, उसका ये मतलब है the water along with cement and sand, they will keep on trying to separate out, and it's actually the water which is offering the medium through which it begins to flow out or move out towards the top, and the heavier particles towards the bottom. So keeping low water cement ratio is always a good thing. Then if you are, the fourth one is heavier coarse aggregates. The heavier coarse aggregates, because they are separating first. They are separating first because they are heavier. So you want the aggregates to have, what should be the aggregates? They should be not too large. That is important, because if they are too large, they will completely segregate out. And because that would be too large would mean too heavy aggregates. They they will have more chances to segregate out. So you want to restrict the size of aggregate. You want to restrict the size of aggregate to a particular size. It is 1 inch, 3 by 4 inch, 1.5 inch. In concrete, you want to restrict it within those sizes. You do not want the aggregate size to exceed, in most of the cases, above 1 inch. So that has to be maintained for restricting the segregation. Then if you are using, if you're doing a wet mix design, in a wet mix design, where you are actually using a total wet mix, there the grout may separate out. I'll explain this wet mix when we reach that stage of the design. So at this stage, I can just tell you it's a wet mix where you are there. You have a large content of water in that mix, or there is a plasticity of the mix is too large, so the grout will begin to separate out first in that case. So you do not want that to happen. Now, apart from these, there could be segregation due to shoot. The shoot I showed you last. These are the shoots that you may use even for the concrete. This is the shoot that you are using for concrete. Now, because this is dropping from a height, although you are restricting an angle here, यहाँ पर 30-degree angle है, he has used a 45-degree angle. So, but there might be sites where the angle would be quite large. Now, if the angle is too less, the chances of segregation are less. More the angle, more are the chances in that shoot of the concrete falling all of a sudden. And जब आप height से उसको fall करवाते हो, what happens is that gravity comes into action. So gravity pulls the heavier particles first. So it's actually separating the heavier particles first, and they move out. वो पहले चले जाते हैं, और बाकी बचता है cement, sand, paste with water, और वो बाद में आता है. So it's actually segregating during that process. And even one more point is vibration of concrete. Now, this vibration of concrete, that has to be restricted to a limit. If you are vibrating the concrete too less, it may not properly achieve the workability if the slump value is less. Now, if you are vibrating it too much, then the particles begin to separate out. The heavier particles begin to separate out first if you're vibrating it a lot. So vibration has to be within the limits. And then how do you actually measure you can also measure the segregation through flow table test. If you use the flow table test, I can show you the picture of flow table test. This is the flow table test. So you can see that he's measuring the how much the flow has happened. That's one part of it related to slump. And the other part you can also check from here, what is the consistency of this paste after it has flowed out, whether it has segregated or whether it has remained the same. So this could be one method of measuring the segregation of the particles here. So next is bleeding. You will again rejoin the session.